Hello, welcome to Local Matters. My name is Vicki Evans. Physicians for Social Responsibility is a national organization. However, it works locally as well as nationally with environmental, civic, and governmental organizations. The goal is to confront the challenges to public health from global warming and the use of nuclear energy as a weapon and as a source of electricity. We're going to learn a lot more today as we welcome Dr. Barbara Warren. Thank you for being here.
Thank you.
And Barbara is the director of the Southern Arizona chapter of Physicians for Social Responsibility, and that is headquartered here in Tucson.
Yes.
And then Russell Lowe's. Thank you, Russell, so
Thank
much
you.
for being here. And Russell is with the local chapter of the Sierra Club, and he is also the chair of that chapter's Energy Subcommission. So thank you both again for being here. Russell, take us back to what happened. And I think I've got the date right? March 11th?
March 11th, 2011.
2011, right?
Right. A few years ago now, there was an earthquake off of the coast of Japan and in the Fukushima area, northeast of the Fukushima area. And that actually started the process of a meltdown. The earthquake itself, contrary to what the media has been reporting. The company, TEPCO, it was called,
right.
TEPCO was the Japanese utility company, claimed that it was the subsequent tsunami that started the whole process. That made it much worse, though, the tsunami. The tsunami inundated the pumps that would cool the plant normally, right. and basically cut off all the power through the force of the tsunami and the grounding out from all the salt water that rushed into the area.
So has it been turned off? That's the question I want to
well,
know. It hasn't really, has it?
There were
it's
three.
Pretty hot.
There were three meltdowns, and they actually melted through. So a meltdown through 12 inches of stainless steel. There were three reactors that all had meltdowns, and during that meltdown process, they also exploded with steam explosions, hydrogen steam explosions, and one of the three reactors was at a higher level of U-235, the fissionable material inside.
Well, when you say and I want that's like a uranium, isn't it?
Right.
It's the radioactive material.
Yeah, and uranium is mostly non-fissionable in terms of sustaining a heat generation, but the U-235, which is a tiny percentage.
Bombs too, isn't it?
Well, yes, U-235 can make bombs as well as plutonium, and there are other couple isotopes, but those are the primary two isotopes that make bombs. And so what happened with this was one reactor had too high of a 235 content, the potent form of uranium that can sustain heat generation, and that one. It had what was called MOX, or mixed oxides. That essentially caused it to explode with a slight nuclear explosion. So you'll see in the pictures, if you see the...
And we've just been looking at them, yeah.
If you see the actual footage of the explosions, two explosions, the explosions are maybe going at this speed. One of them, the explosion is going at this speed.
What has been the result? I mean,
from a distance.
We laymen who know a little about, basically Hiroshima and some kind of atomic weapons, and is that nuclear power plants are, when they're operating, are very safe, and yet I can remember after the Fukushima disaster in 2011, weren't we to be aware on our west coast that prevailing winds, perhaps, Barbara, was going to bring a lot of trouble our way?
We certainly are concerned about that, as well as radioactive material being carried in the water, contaminating the fish and our coastlines. I don't think we have a lot of really good data about that at this point in time.
Well, and also reactors are claimed to be safe, but you need to look at the entire fuel cycle. You've got mining, you've got milling of the ore, you've got all these different steps. There are 20 steps
Right.
of the entire fuel
Right.
cycle. So even when they're not having an accident, there are
Right.
emissions that are going along
Consequences.
the entire
Right.
fuel chain.
What, as you said, data isn't quite good about the effects hitting the West Coast or the United States. What are some of the things that you're looking for as concerned people and activists in this area, and very knowledgeable ones? What are some of the things that would happen in our area that would make us say, "Oh my gosh"?
Yeah, well, there's several things. One is that we could have radioactive contamination of our food and our fish, and then our food through water, through carrying of these radioactive materials. We're also very concerned that we have the same kind of reactor on the California coast, that it sits on in the same conditions, sits on the water, sits on the ocean, it sits on an earthquake fault, and could have the same problems in case of an earthquake. It has been shut down because of those risks and other things that were going wrong at that plant. We're also concerned about the contamination causing cancer, and in fact it is causing cancer now in children in Japan who were exposed from this accident. The first kind of cancer that shows up is thyroid cancer, because it's rapidly taken up by the thyroid gland. And there are at least 120 children now who have been reported with thyroid cancer in Japan, and many others who have had thyroid abnormalities, which could then become malignant.
And that's far above the expected number that would normally occur in that population.
Yeah,
Okay.
it's pretty rare in our country, unless people have been exposed to radioactivity. And so these are the kinds of things we all worry about, and having similar accidents, because there's other similar plants in our country also that were made by the GM and have the same risks.
Right. You know, it wasn't until Fukushima that I even became aware. How many nuclear power plants are there in the United States that are,
Well,
that we use?
there were 104 a couple of years ago, but they've been closing some of the reactors down due to economic reasons and due to mistakes. Like the San Onofre plant in California was closed down because they put in a new generator that was supposed to last many years, and it lasted about 2 years. It was a Toshiba generator, and it was
Right.
very faulty design, or construction at least of the design. And so that one's closed. There are 5 reactors either in process or already closed down. And so that'll bring it down to 99. And then it's 99 reactors on the wall at that point.
What about Phoenix? And you know, the one that's outside of Phoenix?
Well, there are 3 reactors there. And while a plant is running, by the way, they do have normal emissions, what they call normal emissions. Approximately every 8 days, they release gas that has been built up in tanks that has been allowed to decay to legal levels, and then they put that into the atmosphere. Okay. So there is no period of time, except maybe between those 8-day releases, that the reactors are not off-gassing. That's a constant process. And then the pools themselves, where they take the reactor spent fuel out of these reactors and they put them in pools to cool, those pools are off-gassing. And they're not...
pools just next to the plant?
Yes,
Next to the oh my gosh.
They're next to the reactors. And
Right.
in fact, that was the biggest problem at the biggest threat at Fukushima, was the spent fuel pool in reactor 4,
Right.
which reactor 4 blew up through hydrogen explosions.
What, so originally 104, 99 plants left. How do we produce electricity once those are down? And we don't have a heck of a lot of time, so I want to make sure we can get to what, if we don't use these nuclear reactors, how do we produce electricity?
Well, if you look at the distribution of energy that's being produced today, the new energy that's being produced, I think we have a picture of this.
Right.
The majority is in solar and wind, and solar and wind are becoming. The wind is the cheapest form of energy. Solar is becoming more and more affordable. And we can put these in anywhere, but
Barbara,
particularly in the Southwest.
So you mean total consumption of electric
No, the new electricity being installed,
installed?
the majority is solar and wind. Coal, and we're very concerned about the impact of fossil fuels and nuclear energy as well, because there's a lot of release of carbon in the production, the manufacturing and production of nuclear power. Fossil fuels need to go because we have a crisis on our hand with global warming, with climate change. We need to address this problem emergently. As you know, there were 1 million people that demonstrated over the last weekend, and 400,000 in New York City, and many, many more around this country saying, get rid of fossil fuels, it's time to fix climate change. It's very late in the game, and we must do something now.
Okay. And I just want to remind folks that we are talking to Dr. Barbara Warren and Russell Lowes about climate warming, and also the intricacies of nuclear power as an energy source. So if you'd like to learn more about what the Physicians for Social Responsibility, what they do, and become a part of, or just learn more, please go to psr.org/chapters/Arizona. So, yes, go ahead.
Nuclear energy only provides 8% of the energy in the United States, approximately. It's about 19% of the electricity, but only about 8% of the total energy in the United States. Energy efficiency alone, there's a picture that we have on this, energy efficiency has saved us over 50% of the power that we were producing in 1973 when you consider our economic growth. So, you know, per unit of energy or per dollar of economic growth, we're using less than half the energy now to produce that same dollar of goods when you adjust for inflation. So that can actually continue into the future and bring our total energy production down dramatically, way more than the 8% that nuclear represents at this point.
So we only have a couple of minutes left. What would you really like folks to walk away, knowing what Physicians for Social Responsibility, Sierra Club, what's the one thing they should really keep in their...
No more nuclear power plants. No more nuclear power. It's extraordinarily expensive. There are people still trying to build new nuclear power plants in our country and other parts of the world. No more nukes. It's dangerous, it's expensive, and we don't need it. It contributes to our climate change problem, and they need to go.
We'll let Russell have the last word.
On the news this morning, I heard someone say solar has come down so much that it makes sense to build it today. In 10 years, it'll be insane not to put solar on your house. So it is coming down. It's replacing the need for this. That, combined with energy efficiency and energy storage, will make nuclear and coal and fossil fuel essentially a has-been energy.
For the non-believers, if you solar energy is going to be very cheap in the next few years, and there you go. Right?
Yep.
All right.
We all win.
We all win. Win-win. Right. Thank you. This has gone very fast, and I thank you both very much for joining us today. Thank you so much.
Thank you very much.
All right.